All right. So as you're just initially start writing down, gosh dog it, I didn't take attendance. All right. Anyway, shh, silence. This is live. Just so you understand what rational zeros are compared to irrational zeros. There we go. Just wanted to zoom in on this. So first of all, you have to know what a rational number is. It's a number that can be expressed as a fraction, which I put up there. And then I pulled the book example of, okay, look, here's a function f of x equals 4x squared minus 9. Can factor, that's a difference of two squares. I've never seen that before. You're wrong. We factor in here all the time, right? But then you end up getting 3 halves and negative 3 halves. And those are rational numbers. Actually, any integer is rational. 5. 5 is 5 over 1, isn't it, everybody? Can be expressed as a fraction. So what we're going to have next is called the rational zeros theorem. If you don't know what a rational number is, then you don't know what the rational zeros theorem is. Right? And then an irrational scenario. The green, these represent irrational zeros because, oh, you know, and you would not do this for x squared minus 2 equals 0. If we were going to find the zeros, you'd set it equal to 0, and you'd add 2, and then you'd square root both sides. And if you want to get burned again, you won't put what in front of that answer? Plus minus. How many people did that? You know, on that initial test or whatever. Fumble! Okay, but they do it in a factoring scenario, which is not how anyone would really do that, but this is true. X squared minus 2 does factor to be x plus root 2, x minus root 2. What? Anyway, plus minus root 2. Those are irrational zeros. Then I thought for giggles I'd put some popular irrational numbers if we were going to classify numbers, which is you know, something you do in Algebra 1 or Algebra 2. What are those classes? All right. And now we can move on to rational zeros theorem. Oh boy, sorry for the scrolling. And you don't have to write this down. Don't write this down. But I do like to pull out the book, you know, so that if you went to college and had to read a math book on your own, if you're going to take a math, which, you know, that's, I think, why we're all here, the majority of you will, sometimes they're hard to read. And all this says is, here's the standard form of a polynomial. And all this is the top dog leading coefficient, I guess, with the highest degree term. So a sub n is the leading coefficient. And then plus everything lower than that all the way down to the constant, which they call a sub 0. So don't overdo it. It's just a standard what a polynomial will look like. Okay, now you're ready for this? What I have in highlighting, I have in my own writing to synthesize this, which you've already seen. Right? You ever hear of the P over Q list? Huh? So the first thing we're going to talk about is writing a P over Q list for all possible rational zeros for a polynomial. And they come from the following. Well, the book does elegantly show it. Look at what I have highlighted in, green. This top one that I'm pointing at. P is an integer factor of the constant. So that's what I wrote over there with my plus minus P over Q in my writing. All factors of the constant is what P represents, divided by all factors of the leading coefficient. Highlighted in yellow up here, what the book wrote, Q is an integer factor of the leading coefficient a sub n. This is the only possible rational zeros for any polynomial. Of course, we have not talked about, or this does not cover, irrational zeros. And what other kind of zero can you have? Irrational zeros, or it does start with an I. Imaginary zeros. Did you say that right? Why is he laughing? Did you say imaginary, or did you make up a word? All right, here we go. Shh, back. Okay, now, understand the difference between possible rational zeros and actual rational zeros. This first example says find the rational zeros of this. That means find, how many possible zeros can I have, by the way? 3. That's the fundamental theorem of algebra, which I think I officially write in tomorrow's notes or pulled from the book, as you know I do. But if it said in the book, if the direction said, please listen, find the possible, I guess I don't have to write that, find all possible rational zeros. You don't actually find which zero is there. You just make the list of the possibilities and you move on to the next one. You got it? And I know that happens in the homework. They get so sad that students don't read that word possible and they keep going. So let's pretend that's what this says. Well, this one's a stupid one because what are the factors of P? Where does P come from? What number am I looking at? 1. How come no one else said that? What are the factors of 1, guys? What are the factors of 1? 1. And by the way, you do put a plus minus here. And then where does Q come from? What's the leading coefficient? 1 again. This is redonkulous. So if the question said find all possible rational zeros, you'd be done. And that's it. Now you do know zeros can happen multiple times, right? So 1 could happen 3 times. -1 and 1 and 1. Or they could happen no times, which is actually wild for this one. But you know what? That's not what these directions said. They said find the rational zeros. So that means actually find out if these are really zeros for the function. And the only way you can do that is through the glory and power of... What am I doing, everybody? What am I doing, everybody? Synthetic division. Hey, what's next? No, I'm not done writing the polynomial. What's next? 0. Focus with us, man. Focus. Bring down the 1. That's the first step after you... Okay, so again, you're missing an x term, so you must account for that with a 0. 1 times 1 is 1. By the way, I'm not doing this synthetic division like this anymore. I'm going to show you a little different way coming up here. Oh, so close. Is 1 a 0? Yes or no? Well, is 1 a 0? Yes or no? What am I supposed to get if it is a 0? At the end, I'm supposed to get a 0. And then synthetic substitution would mean that 1 was inputted, 0 was outputted. In this case, 1 was inputted and you got -1 as an output, right? Isn't that what synthetic substitution says? That's what, if you did your homework, which I saw some people didn't. Good luck. All right? Don't complain. All right? If you don't do your homework, right? That's your job. Remember I told you about, nothing against your parents. I don't want to talk to your parents. They all seem very nice. I have had some that wanted to kill me, I think. But that's fine. Hey, it's me and you. You're 1 year away from college. Let's start acting like those college students do. 1, -1, no. Unbelievable. Unbelievable. 4. Is this even close? Did I even do that right? -1 plus -4. -1 times -4 is 4. 4 plus 0 is 4. So not a 0. So what does that mean if these were the only possibilities and they're not zeros? What does this mean? So, well, maybe not. They could be irrational, right? Which is wild. If they never cross or didn't cross, then it would be imaginary. Actually, it'd be impossible not to cross at least once, because this is a positive x cubed. So it'd either have to hit there or... And actually, when we look at this, I think it does cross 3 times. So all 3 zeros are weirdly irrational, which it is actually a weird scenario to have that happen. Okay. Anyway, let's move on to the next one. Is this listing a list of possibilities, or are we actually finding the zeros? We're actually finding them, but it is nice to start with a list. Okay, because I will tell you, this is what I did to the students of the past. We didn't, this whole section was no calculator. The whole section was no calculator. So what they have to do is do the P over Q list, and then from the list, they had to start by trial and error to figure out who was a 0 or not. And I'm going to emulate that game with you right now. Okay, so first of all, where does the P come from? The factors of 2. And don't care about the -2. It's just you have plus minus. So that takes care of that. 1 and 2. This is how I write it. Now watch. What are the factors of Q? Or what's Q? What are the factors? 1 and 3. And then this is how I construct my list. I go plus minus. I am lazy. And I put plus minus parentheses, fumble. And then what I do is I do all versions of division on this. And I do the whole numbers first, or the integers. 1 over 1, 2 over 1. So plus or minus 1, plus or minus 2. Then I go fractions. 1 over 3, 2 over 3, right? So I just I go about all numerators all over all denominators. And if there are repeats, then you don't write the repeats, and that happens in the next one. So how many possible rational zeros are there? Don't say 4. 8 plus minus, right? And then what the students of the past had to do was start checking, are these actual zeros? Now watch, for those students of the past, I'm going to show a different way of synthetically dividing. But the first one actually works, so unfortunately. You know what? Let me do -1 first. So we'll show you why I do what I do here. 3, 4. Are there any missing terms? -5. Did I make a mistake here? Are there any missing terms? Just bear with me. I think you've done synthetic division. Unless you didn't do your homework, I can't help you. Only you can prevent forest fires. I don't know. Uh-oh, what is that? I hit my arm, and then this car comes up. I do want a truck, though. Ooh, that looks good. How do I get out of that? Oh, for the love of dog. I don't even know how to get this thing. I don't even know how I close that. That gets, do I swipe it? What do I do? Oh, geez. Let me pause the video. Oh, it's gone. Okay, it left. All right, let's move on. Shh. Okay, here, watch. This is how you do this. Okay, wasn't the first step for synthetic division bring down to 3, right? So just bring it down here, and I'm going to show you why I'm going to do this, because it helps you with trial and error to find out if something is a 0 or not. And all I'm asking you is to hold the addition in your head, because isn't the next thing that you took -1 times 3, right? What's -1 times 3? Hold. What's -3 plus 4? 1. And then you write the answer. So we're just doing the addition in our head. We don't have to write it down. Somebody's head's about to explode. Okay, what's -1 times 1? Hold. -1 plus -5 is? -6. Is this going to be a 0? Are we going to have this? Is it going to happen? No, but 6 plus -2 is 4. What this means is it's not a 0, so I'm going to check something else. And then you see why I don't have to keep rewriting 3, 4, -5, -2, and I can keep going. You got it? As long as you can hold the addition. If you want to do the old way, go ahead. I don't want it erased, though, but then if you have to do a lot of checks, there's a lot of writing. All right? Someone's excited because they worked ahead. Bring down to 3. What's 1 times 3? 3, Mr. Samuelis, plus 4, 7. So you hold the addition in your head, do it in your head, and then write the number. 1 times 7 is 7. 7 plus -5 is what? Who's excited? 1 times 2 is 2. 2 plus -2 is 0. That means this is a 0. So here's one of my answers. So if I have a spot for my final answer, zeros. The zeros are, well, one of them is 1. How many zeros should I have? How many zeros should I have? 3. Remember this? This is now a depressed polynomial. Aww. So it's a depressed polynomial. You know what a depressed polynomial needs? It needs to be worked with. Maybe it needs the depression bear over there. Or no, the anxiety. What was it called? Anyway. I covered up that sign. Now we're going to find the remaining zeros. How can you find the zeros of an x squared? Through factoring, or, sadly, some people use the quadratic formula on their last quiz on this question. And this is, again, I'm going to yell at you if you don't get this. If you don't get that 3x squared comes from 3x and 1x, good foilers, anyone? Because I still got people doing their little methods, and then they write an answer that's not sensical. Doesn't make any sense whatsoever. You know, they write x and x. Again, you are not at this level, and you need to get there. Hey, what equals 2? What times what equals 2? And then all you have to do is choose where does it go. Does the 2 go first or second? It is second, because then what you get is 6x and 1x is 7x, the middle term. Good FOILers, anyone? See, that's what I mean about good FOILers being good factors. Oh, we're making other math teachers mad. You're teaching FOIL? You're gosh darn right I am, because that's the best way to understand factoring. And factoring fast. All right, by the way, what are the other zeros? Negative 1/3 and negative 2. And lo and behold, they are in my, anyone? They're in my, I'll point to it, list of possibilities. These are the actual ones, though. All right? All right. Okay, so we can move on. Okay, now get ready for this. Are you ready for this? Boom, 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 boom. This is what I made the students do in the past. They were not allowed to use a graphing calculator. Actually, I took the calculator a lot away from them back in the day to make them work with numbers and get numerates, because it's important in this class. So here's this polynomial. And then notice what it says in exercise 49 through 56. Find all. What does that say? What's that word right there? Find all of the real. It doesn't say rational. It says find all real. That means rational or irrational as well. Okay, and P over Q just for fun. Plus or minus P over Q. Just to get your possibilities for this. Then I'm going to show you what the students had to do. Hey, what are the factors of 6? 1, 2, 3, 6 over, what are the factors of, oh, I don't want you to see that yet. What are the factors of 2? 1 and 2. And then this is how you construct your list. Plus or minus, parentheses, let's be lazy, meaning all of these are plus minus in front of them. All of these numbers over 1. So 1 over 1, 2 over 1, 3 over 1, 6 over 1. Because the students back in the day, I told them, hey, usually the book's nice, and usually they get like 1, negative 1 works, or 2. They don't make you go through a lot. And then, I'm not done yet. Now all the ones over 2, 1/2 for sure. Hey, what's 2 halves? 1. 3 halves? Hey, what's 6 halves? 3. You don't write repeats. So there's your P over Q list. That's the way I like to write them. Whole numbers first. I'm sorry, I should say integers first, plus minus, and then fractions. And then I said, okay, students, let's roll with it. Then back in the day, if I still had this video, this is what I did. I tried 1. I know you can't see it. Boba Fett's head's in the way. Sorry. Bring down the 2. 1 times 2 is 2. 2 plus negative 3 is negative 1. 1 times negative 1 is negative 1. Negative 1 plus negative 4. So close. Negative 5. What's 1 times negative 5 plus 6? 1. That means 1 comma 1 is a coordinate, not 1 comma 0. Now you don't have to write this down. Then on the video in the past, I tried negative 1. Then I tried 2. Then I tried negative 2. Then I tried 3. And then I tried negative 3. And then I tried 6. And then I tried negative 6. None of them worked. You know why I stopped early? Look at this. Look at 6, for instance. You bring down to 2. What's 6 times 2? What's 12 plus negative 3? 9. And then this is starting to take off. 6 times 9 is what? 54 plus negative 50. Who cares that that's not going to get to 0? It's like not even close. So actually when I was going through this, I was like telling the students, I'm not going to keep going. I know I'm not getting a 0 out of these. All right, so I should make you go through that process, but I won't. You know what the first one that works is? 3 halves. And then I'll show you some skills that you can use in order to do what we're going to. And I'm going to do the old way because I'm going to tell you that this does work. Negative 3. So I'm going to do what we did with the little garage thing there. I call it an upside down garage. And then draw the line. And then we'll do it the long way. Bring down the 2. Hey, what's 3 halves times 2? This makes me sad. How many people don't know this in a millisecond? It's 3. What's 3 plus negative 3? 0. Nice. This is the old way of synthetically dividing, writing the numbers down, then adding them. Oh, come on. Times 0 is 0. And then do you know what 3/2 times -4 is by chance? It is -6. 2 goes into -4. -2 times, -2 times 3. All right, you know what you have now? And by the way, what does it say? Find all the zeros. You have a depressed polynomial. Aw, let's work with it, shall we? 2x squared minus 4 equals 0. What are you going to do next, everybody? Add 4, divide by 2, right? And then unless you want to get burned again, what's the final answer? So x equals 3/2. And then what do I put in front of that? Plus or minus √2. There's our 3 zeros. Let me take a break for a second. All right. So I just bemoaned the fact that students back in the past had to do a lot more by hand. And I think it was kind of good that they went through this process without a calculator. But I understand the reality of things these days, and we are trying to sink that stuff down. But I do believe this is why we have some numeracy issues. We're doing less by hand and more by calculator. Anywho, that's me complaining again. Use the graph to guess possible linear factors. Then, look at what it says. Completely factor. Remember that thing? Zeros are x-intercepts for a graph, and they turn into factors for the polynomial. So it's very simple. The last two questions, I could have put it in factored form instead of, reanalyze the zeros and make them factors. All right, so that's what we're doing here. And then notice what it says, with the aid of synthetic division. Here we go. Boom. Oh, boy. Oh, boy, that's great. Yeah, I got to turn off. Hold on. I got to turn off my email. All right, so how is this graph going to help me? Look at this. You see this first zero? What does it look like it's at? I actually put the number on the screen. -3. What's the other one look like? What's the other one look like? A decimal, fraction. So with the aid of the picture, I'm going to go old school. I'm going to go back to red. Old school, well, not old school, what we talked about Friday. And I'm going to pick one of the two that it looks like those are the zeros and prove it. So I'll pick the 1. X-intercepts are zeros, so they should be 0 when I plug them in. Or when I use what's called synthetic substitution, which was another part of your, what you should have done for your homework. And if you didn't do your homework, that's right. Bring down to 5. What's 1 times 5? 5 plus -7. -2. 1 times -2. -2 and -49, -51, right? And then, hey, look at this. -51 plus 50 is 0. Proved. Hey, what's that 5, -2, -51 called? Now, this makes me sad how many students don't catch this. I don't know why I'm trying to change colors. 5x squared now minus 2x. You expect me to factor this? That's a tough one. You want me to multiply 5 times -51? You're not thinking. Look at the graph again. What is definitely one of the factors for sure? Well, -3 is a 0. What is that as a factor? One of the factors is x plus 3. Use the graph in order to know that one of the factors is that, and then be a good foiler, because good foilers are good factors. What does that have to be so that it foils correctly? 5x. And then just for giggles, what times what equals -51? What kind of 17, though? Boom, shaka, laka. And then if I want to write the final answer for this, what is this in factored form? 1 is a 0, so x minus 1 is a factor. And then the other two factors I found from factoring the leftover. All right, I still probably would have done my unfoil without doing the multiply thing. Sorry, that's a 17. But I used the graph of the other 0 that I saw that was a nice integer. And since it was a nice integer, it's a nice factor that's not fractional. And then I could just undo the other part by thinking about FOIL. And that's really what everyone should be doing at this point. This leads to this kind of question, number 54. And all I'm going to put there, let's go back to finding zeros. Although I could find the factorization of it just as easy after. I just showed you how to do that. It's almost the same question. And then if you were the students of the past, you would have had to make a P over Q list, and then you were going to have to guess and check. Can that take a long time, though? Yes or no? Can that be frustrating? That's what we're trying to do. We're trying to lower the frustrations. All right? So you know what we're going to do? We're going to go to the calculator. We're going to graph it. Because of time, first hour I did it, I opened up the calculator. It takes forever to open. It wasted like 3 minutes. So I put it in the graphing calculator and then got this picture. And then I did do y2 equals 0, but then I stopped. So I'm like, I don't need that. Look, I can guess. Doesn't that look like, just like in the last picture, doesn't it look like -1 is a 0? Doesn't this look like it's a decimal, the one on the left? Well, I'm going to avoid that one. You know why I need 2 zeros? And hopefully I do find 2 that are nice. By the way, that looks like 2 is a 0. It does cross and go through, but it looks like it does cross through 2. I'm going to prove it. Does anyone know why I need 2 zeros in this x to the 4th? Because I'm going to double, anyone? I'm going to double, knock it down. I'm going to double what? What's the word? Let's make it so sad. I don't want to make it sad once. I want to make it sad twice. I'm going to double depress this thing, man. I'm going to knock it down, just like Samuelus has gotten knocked down in life numerous times. But you know what he's done? He's always gotten back up, baby. All right? All right, so here we go. We're going to start with -1. -1. 1. You know what I just watched this weekend, by the way? Batman. I watched the Batman. Why do we fall? So that we can pick ourselves back up. So I watched the first one and then part of the second one with the Joker. The original Joker. Or anyway, bring down the 1. And you know why I'm going back to the old school? What should happen? According to the graph, this definitely should be a what? 0. -2 times -1 is 2. 2 plus -7 is -5. -1 and -5 is 5. 5 plus 5 is a boom shakalaka. Now, I always teach about common errors, and they still happen every year. At some point, all the planets and stars will align, and all the students will listen to Mr. Samuelus about how students of the past make these same errors, and they won't make them. Okay? So here's what I'm going to lament about. Do I take 2 and then synthetically divide this by 2, yes or no? No! Because you know what I got right now? I have an x cubed right now, right? If I synthetically divide this by 2, I am just going to get another x cubed. We want to get it down to an x squared, because what can we do with x squareds? We can factor or use the quadratic formula or some other method of solving that is easy, like you'll see in this one. So what I'm going to do is, this is gone now. This is now an x cubed, x squared, x constant. And then I'm going to take that other 0 and knock it down again. I'm going to knock this down from an x cubed to an x squared. That's the most common error, what I just said. People take that 2 and then go back to the original and synthetically divide the original again. Then you just have 2 different x cubes. All right? And you got to understand that. All right? All right. Quicker you do, the better. That's why I color code this like this. 1, 2 times 1. Oh, this is actually nice what happened here. 2 times 0 is 0. Which is -5, 2 times L, boom, shakalaka. So I'm not looking at this wrong. It could have been a little bit off, but it looked like 2 was a 0, and now I proved that it is. And now what you have is an x cubed, I'm sorry, an x squared. Ooh, someone yelled, wrong. I guess I do that sometimes. And then what are you going to do? Add 5. And then root it. And how many zeros are there supposed to be? Zeros. There's supposed to be 4. So what's missing? Again, no excuse for the burn rule. You can't get burned on it over and over again. When you square root both sides, you put a plus minus in front of the answer. And there are 4 zeros. So root 5 is some decimal. And that's what those other two zeros represent, the decimal representation of what root 5 is. Square root of 4 is 2, so square root of 5 is 2 point something. Huh? Yeah. All right, and then now for something completely different, but not really. Then they end with this kind of question. And I have the answer there, but I'm going to prove it. I will say you want to leave this answer in factored form. You don't want to be a FOILer anymore. Remember we had questions like similar to this, where you had the zeros and then you had to come up with the polynomial? Well, now they add a fourth point. Oh, and I shouldn't assume anything. What is negative 4 comma 0 called? A 0 or an x-intercept, which turned into factors. Factor, a factor, a factor. Now, this does not have to be this point, but what is that point for the polynomial? It is a y-intercept. This could be any arbitrary other coordinate. And the point of that coordinate is it's a little bit more better. What? It's a little better than the questions we had in 2-3. But this is actually, we'll have a unique a value now because that other coordinate defines what the a value is for this polynomial. So what you do is you start off and say, okay, the zeros are, okay, hold on. I don't know who did that. F of x equals, well, I don't know what a is, but I know minus 4 or negative 4 gives me x plus 4 as a factor. 3 gives me x minus 3 as a factor. 5 gives me x minus 5 as a factor. And then where am I going to plug in 0? Where am I going to plug in 0? You're going to plug in 0 for the x's. And where am I going to plug in 180? For the y, or f of x. And then you're just going to be a simple solver for a. Now again, this could be any coordinate. It could be 7 comma 88. You'd put in 7 for x. Don't tell me that's difficult. What's 7 plus 4? 11. What's 7 minus 3? 4. What's 7 minus 5? 2. And you could just solve just like I'm going to do on this one. So please understand, it does not have to be the y-intercept. They just chose this particular coordinate. And then what does that become? 0 plus 4 times 0 minus 3 times 0 minus... Don't distribute. I heard foil. People start foiling. What's 0 plus 4? Oh my gosh. 4. What's 4 times negative 3? Negative 12 times negative 5. So you get 60. And now you can see where the a come from. 60a. And then I have people do that. They start, what? Those are numbers. Just go ahead and evaluate them and then multiply. And then you can see why. Do not multiply this out. Okay, so leave the final answer in factored form. The whole point of this is to find what is that a value. And I'm telling you, this coordinate right here determines what that a value is. All right, now we're done.